Okay, here goes. One of the first things we covered after the first exam was clock arithmetic. This was to sort of help set us up for looking at working in a system that's not just your standard base 10 system that we work on all the time. And with clock arithmetic, if we have an 11 clock, one of the ways you can approach this is actually by just drawing the clock. And we would have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. It doesn't have to be a work of art. But on an 11 clock, those would be our numbers. And if I wanted to add 9 plus 4 plus 9 plus 14 plus 6, one way that I could do that is I could count around this clock until I got there. Another way that most of you probably did was just did 9 plus 14 plus 6 and see what you come up with. And that's 29. The problem is 29 can't be our answer here because when I look over here at my 11 clock, 29 is not on there, so it can't be an answer. So what I need to do is I'm going to do one revolution around this clock backwards. And the way I'm going to do that is subtract 11, and that puts me at 18. That could be an answer. The problem is when I look at this 11 clock, 18 is not on there. So that can't be the answer. So I need to do another revolution backwards around the clock. So I'll subtract 11 from there and end up at 7. 7 is on my 11 clock, and so that's a possible answer here. And sure enough, our answer is 7. If I add 9 plus 14 plus 6 on an 11 clock, I end up at 7. And you could, the other way you could do this is just count around till 29. You go count around, there's 11, 22, 23, 24, 25, 26, 27, 28, 29. Sure enough, we're at 7. As we go through these problems today, I'll probably do them a little more quickly than we did the first time you ever saw this material. We won't be doing any polling, but just because we're going a little quicker the second time through the content and just because we're not doing any polling doesn't mean you can't ask questions. If we do anything today that you want to ask a question about, make sure you do that. After clock arithmetic, we also did modular arithmetic. And modular arithmetic is very similar. You can draw a circle and count around that circle if you want to. A key with modular arithmetic, though, is unlike clock arithmetic, modular arithmetic does include a 0. So here we would have 0, 1, 2, 3, 4, 5, 6, 7, and 8 would be our biggest number. In a mod 9 system, very similar to our base 10 system. In a base 10 system, the biggest single digit we have is 9. In a mod 9 system, the biggest single digit we have is 8. And so that would be our mod 9 system. If we wanted to add 5 plus 2 plus 8 in the mod 9 system, we could add those up and get 15. Just like with clock arithmetic, though, the problem here is when I look at my modular system, 15 is not one of the numbers, so I can't do that. I need to do one trip around this backwards. It's a mod 9 system. You'll notice there are 9 digits. So one trip around this backwards means subtracting 9 from this. I end up at 6. 6 is in the mod 9 system, and that's going to be our answer here. Here again, if you wanted to count around 15, you could. You would start and go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. You'd start counting at 1 though, because that's where we start counting. It's just when you got around when you went all the way around the horn, you'd get to that 0. Also, after we did clock and modular arithmetic, we looked at what comes after and what comes before. A key here is an understanding of bases other than base 10. If we're in base 6, keep in mind that these are the only digits that we've got. 0, 1, 2, 3, 4, 5. That's it. So in the base 6 system, that's all we've got. So if we want to know what comes after 405, well, I can't put a 6 here, so it's not going to be 406. 6 doesn't exist. This column is going to go up to a 0, so I'm going to have to bump this column up by 1, and I'll have 410 base 6. You'd just put 410. You wouldn't put the subscript 6 on there. You'd just have 410. As we go through these, you let me know if there's anything you want to ask about. What comes before? I kind of think these are a little bit more challenging than what comes after, but you may not find them that way. This one is in base 5. What comes before 3, 4, 0? A key here is recognizing that in base 5, we have those 5 digits, 0, 1, 2, 3, 4. That's it. So when this 0 has to go down, if this were base 10 and I go backwards from a 0, it would be a 9, the biggest digit that we have. So if I go backwards from 0 in base 5, I go to the biggest digit that we have, that's a 4. And then in order to go backwards, this has to go down by 1. This one can stay the same, and we're at 3, 3, 4, base 5. And your answer would just be the 3, 3, 4. You wouldn't include the base 5 part because that's hard for Canvas to grade. All right, must be doing pretty good. Arithmetic and other bases. If we want to add these in base 8, the key here is because it's base 8, if we're going to carry, we're going to carry 8. So if I do 2, 3, 5 plus 4, 1, 6, and we're working in base 8, 5 and 6 would be 11, but I can't have 11 in base 8. So what I have to do is carry 8 of those 1s over to the next column. So I'll carry 8 of them, put that over there, and that leaves 3 back here in the 1s column. And then 1 plus 3 is 4 plus 1, that's 5. That's okay. 2 and 4 is 6. That's okay. And I end up with 6, 5, 3, base 8. The key here is in adding in other bases is if we carry, we're carrying 8. Again, always let me know if you have questions. If it all feels really comfortable, that's fantastic. I won't be shocked. Our quiz scores over the last 4 weeks have been really good, but I also don't want you to be shy about asking questions. Subtraction. Now we're in base 6. A key here is if we're going to borrow, we're not going to borrow 10, we're going to borrow 6. So if I want to do 534 minus 125 in the base 6 system, I'll start by trying to subtract there in the 1's place. Now 4 minus 5, I can't do that. So I'm going to need to borrow. This is going to go down by 1, but when I borrow, I'm borrowing 6. So this becomes 10. Then I can do 10 minus 5 is 5. That's perfectly okay. 2 minus 2 is 0. 5 minus 1 is 4. And end up with 405, base 6. Let me know if you have any question about that. Okay. Converting to base 10, we'll also do converting from base 10. But if I want to go from a different base to base 10, if I have 606 base 7 and I want to turn that into base 10, the key here is recognizing that in base 7, our place value positions are 7 to the 0, that's 1s. 7 to the first, that's 7s. 7 to the second, that's 49s. And that's as far as we need to go because we can see that this number ends at the 3rd place value position. Okay, so that means, excuse me, what I have here in this particular problem is I have 6 49s plus 0 7s plus 6 1s. So to write this as a base 10 number, I just need to evaluate that. 6 times 49 is 294. 0 times 7 is 0. 6 times 1 is 6. Adding that together, we get 300. So if we wanted to write 606 base 7 as a base 10 number, it would be 300. What we're saying here when we do this is that 6 49s plus 0 7s plus 6 1s is the same as 300s plus 0 10s plus 0 1s. We're saying that those things have the same value. Okay, sailing right along. Going from base 10 to a different base. Now this is a little more challenging than the last one. In the last one, we just had to multiply and add. In this one, we have to divide and subtract. So it's a little more challenging. But if I want to convert 152 base 10 to a base 5 number, again, we need to make sure we establish our place values. We'll have 5 to the 0, that'll be 1s. 5 to the first, which will be 5s. 5 to the second, which will be 25s. 152, I'm not sure. I'm going to go ahead and check. 5 to the third will be 125s. Okay. Let's see. And what if we did 5 to the fourth just to check? I don't think I'm going to need any 5 to the fourth, but I'm going to go ahead and check it. That would be 625s. I'm definitely not going to need any 625s to write this number. So I don't need any of those. But I might need 125s, 25s, 5s, and 1s. So we'll start out by seeing how many 125s do I need to write this number. And we'll do 152 divided by 125, and I get 1 point something. Now, I don't care about the something, I care about the 1. That means when I write 152 as a base 5 number, I'm going to need one of these 125s. Then I have to see how much of the 152 did I just take care of. Well, I had 152. I just took care of 125 of it. So what does that leave me with? 27. So I still need to write 27. Now, some of you can probably just finish it from here. If you can, that's fantastic. Others might want to just go back through the process again and say, okay, now I'm trying to write 27, and I have these place value positions to use. So first I want to see how many 25s it will take. So let's see, 27 divided by 25, that's going to be 1 point something. I don't care about the something, but I need 125 in here. Now I want to know how much of this number did I take care of. 27 minus 25, which leaves me with 2 that I still need to write. Well, I'm not going to need any 5s to write 2. I'll need 2 1s to write 2. And so as a base 5 number, 152 would be 1102 base 5. Your answer, just the 1102. You wouldn't put the subscript 5 in. Let me know if you have any questions about that. I think that's probably the most challenging thing we've seen up to this point in our review. If you're comfortable with that, that is fantastic. Okay, outstanding. We looked at some other number systems. Hindu-Arabic, which is the number that we use, number system we use, to Roman numerals. If we want to write 1974 as a Roman numeral, these will be given to you on the exam if you need them. You don't need to write them in your notes. You might have them memorized. That would be even better. But if I want to write 1974 as a Roman numeral, I'm kind of do this by place value position. First, I'm going to look at that 1000. Well, I have 1000. That's just an M. Now I want to write the number 900. Well, I could do 504 of these, but we never do 4 of a thing. Instead, we'll subtract. And I want to take 100 away from 1000. That's how I'll get 900 here. So for that, I'm going to do CM. So there's my 1900. Now I need 70. That's just 50 and 2 10s. And then I need, wait, I did it backwards. How about a 50 and 2 10s? Somebody was going to catch me on that, I'm sure. A 50 and 2 10s to get 70. And then I need to write 4. And here again, I could do 4 1s, but we never write 4 of the same symbol. Instead, I'm going to do subtraction here and do 1 taken away from 5. So I put the 1 first and the 5 after, and that's the 4. And so here I have my number that is 1974 written as a Roman numeral. Let me know if you have questions on that. Babylonian numerals were kind of a different thing. They only had 2 symbols, this vertical symbol and this horizontal symbol that we wrote as a capital letter I and a less than symbol is how we wrote those. And that's how you'll type those in. And if we want to go from Babylonian to Hindu-Arabic, it's important to remember that Babylonian numerals are base 60. So really what we're doing here is we're kind of going from base 60 to base 10. Similar to what we did in an earlier problem where we had a base 7 number that we had to turn into base 10. Here we have a base 60 number that we're turning into base 10. And as far as our place value positions go, we can tell from the little gap in between. This is 10, 21. So we have 21 60s. And then we have 10, 11, 12, 13 ones. Just to be a little more explicit about that, we have 60 to the 0 power, that's the ones place. 60 to the first power, that's the 60s place. And that's as far as this number goes. When we look at this number, we have our ones, and then we have our 60s. And there's a space between them. That's one way you can tell. Also, the symbol changed. We went from having one symbol to a 10 symbol, so the place value position must have changed. Even the space being in there helps us, but so does the change in what symbol has been drawn. And so now that I've got that all figured out, I've got ones place and the 60s place. I have 13 here and 21 here. So that means I have 21 60s plus 13 ones. We'll figure out what the value of that is. 1,260 plus 13. So that Babylonian numeral has a value of 1,273. To rewrite that Babylonian numeral that is here as a Hindu Arabic numeral, it becomes 1,273. Let me know if you have any questions on that. Babylonian symbols are a little bit new, probably, and the idea of base 60 can be challenging if you let it. Okay, outstanding. Now we'll go the other direction, from Hindu Arabic to Babylonian. Now in this one, we're going from base 10 to base 60. So this is going to be the divide and subtract. This is probably the most challenging thing we've seen today. Since we're going to base 60, we're going to have a ones column. We're going to have a 60s column. And then we might have 60 squared, 3,600s. No, we won't need any of those. The number we're converting is 861. So we're not going to need any 3,600s to write that number. So the first thing we try to decide is, okay, how many 60s are we going to need? And we'll do 861 divided by 60. And 14 point something. Don't care about the something, but it tells me I'm going to need 14 60s to write this number. Now I need to see, okay, how much have I taken care of so far? Well, it's not like the ones we worked on earlier where I could do the multiplication in my head. Here, I need to go ahead and do 14 times 60 to figure out how much I've taken care of so far. That's 840. So the number that I'm working with here is 861. I've taken care of 840 of it, which leaves me with 21. The only other place value I have left are these ones, so I'm going to use 21 of them. So to rewrite 861, I'm going to use 14 60s and 21 ones. Okay, to write that as a Babylonian, we'll have 10, 11, 12, 13, 14, leave a space, type in a space, and then 21. And so if I want to rewrite 861 as a Babylonian numeral, it's going to be 14 60s and 21 ones, and that's going to look like this. Let me know if you have any questions on that one. Okay, very good. Now we get to add, subtract, multiply, divide, the last couple of weeks. And as we looked at addition, subtraction, multiplication, division, properties were a very important part of that. One of the properties we looked at was the commutative property, and that's about order. And that's the idea that 4 plus 7 is 7 plus 4. I can change the order they're in and still have the result of the problem be the same. Commutative works for addition. It also works for multiplication. Does not work for subtraction, does not work for division. So these are properties that work for addition and for multiplication. Commutative is about order. So if you see a problem where the order changes, then that's a problem that's showing an example of the commutative property. The associative property is about grouping. You can see here 2 times 3 times 7, that would equal 2 times 3 times 7. And notice the order hasn't changed. 2, 3, 7, 2, 3, 7. The order hasn't changed. What's changed is the grouping. 2 and 3 are grouped together. 3 and 7 are grouped together. So between the left and the right-hand side of that, it's the grouping that has changed. That's what makes it an example of the associative property. The identity property is one where, is there a number we could add and get the same number back? Is there a number we could multiply and get the same number back? It works for addition. It works for multiplication. It does not work for division or subtraction because it has to work in both directions. 0 plus 5 is 5. 7 times 1 is 7. It has to work both ways in order to be an identity property. Zero property of multiplication is that if we multiply anything times 0, we get 0 back. Just as simple as that. We'll talk about 0 and division in just a second. If there's anything on there you want to ask about, now is a great time for that. Okay. Division and 0. That's an important distinction to make. 0 divided by 22, and if you're happier writing it this way, that's perfectly fine. 0 divided by 22. That's, I have nothing and I want to make 22 equal piles. Sure, each pile gets nothing in it. This is okay. This is just equal to 0. 22 divided by 0, though, the one down at the bottom, if I try to do 22 divided by 0, now I have 22 things, and I'm trying to put it in 0 piles. Well, that's impossible. I already have a pile of 22 things. I can't make 0 piles out of this. I can't do it. Exactly. This is undefined. So while we can do 0 divided by a number, we cannot do a number divided by 0. That's undefined. Closure was something that came up when we talked about the properties of different numbers. And a couple of true or false. The set of integers is closed under subtraction. First, we have to make sure we know what integers are. Integers is the set of whole numbers and their opposites. So that goes on to negative infinity, -2, -1, 0, 1, 2, and goes on forever. So that's a set of integers. Once I know what integers are, now I can deal with this question. It's closed under subtraction. So what's that saying is anytime I subtract 2 integers, do I get an integer back? Something to put some stress on this as we look to see if it's true or not is, well, that's an integer minus an integer. I got a negative. Oh, but that's integer minus integer gives me integer. So that's going to be true. The set of integers is closed under subtraction. Yes, sure enough, this is a true statement. If this question had been the set of natural numbers, which natural numbers are just 1, 2, 3 on forever. If that question had been natural numbers closed under subtraction, then 2 minus 5 is -3 would make that false because I did natural number minus natural number and I got something back that's not a natural number. So while the set of integers is closed under subtraction, the set of natural numbers is not closed under subtraction. At the bottom, the set of whole numbers is closed under multiplication. Well, just like before, we better make sure we know what whole numbers are. Oops. Whole numbers are the natural numbers plus 0. So that's 0, 1, 2, 3, and that goes on forever. And the set of whole numbers is closed under multiplication. If I multiply any 2 of those, we get a whole number back. I don't know, 5 times 7, that gave me a whole number. Okay, let's put some pressure on this and try that 0. 0 times 3, oh, 0 is a whole number though, so that's okay. Yeah, the set of whole numbers is going to be closed under multiplication. Make sure you're comfortable with those 3 sets, whole numbers, natural numbers, integers, and the idea of closure. It could be subtraction, division, multiplication, or addition, any of those. Okay, our standard algorithms. If we are going to subtract, and what we're going to subtract here is 762 minus 381. If I want to subtract those, what is being borrowed? And you've seen this on quizzes, so you're probably pretty comfortable with how a question like this would be asked. Well, 2 minus 1 I can do, but then when I go 6 minus 8, I can't do that. So I'm going to have to borrow here. I'm going to have to reduce this by 1, and I can make this bigger by 10. But keep in mind what I'm borrowing here. Yes, as far as what I wrote down was, I reduced it by 1 and I made it bigger by 10. But what I really did was, I borrowed 100 because 1 in the hundreds column has a value of 100 from the hundreds column and added it, or I guess I moved it is a better way to say that. I moved it to the tens column. So I borrowed 100 and moved that over to the tens column. Now we might as well finish this since we're this far along. 16 minus 8 is 8. 6 minus 3 is 3. And we end up with our answer here. Key here is that we're borrowing 100. We're not borrowing 10. We're not borrowing 1. We're borrowing 100 because we borrowed it from the hundreds column. Another standard algorithm question. If we multiply 314 times 85, what are the numbers that are multiplied together to give us 25,120? I think a way to approach this is just do it. Do 314 times 85 and see how it plays out. 5 times 4 would be 20, and we'll put the 2 up there. 8 times 1 is 8, and 2 is 10, and we'll put the 1 up there. 5 times 3 is 15, and 1 is 16. Hang on a minute. I knew when I wrote that 2, something didn't feel right. How about we do this? Start this one over again here. I'm going to use a different color. 5 times 4 is 20. We'll put the 2 up top. 5 times 1 is 5, and 2 is 7. And then 5 times 3 is 15. There we go. I somehow got a little sideways. I apologize for that. Okay. Then on our next row, we'll have, and I'll do that in a different color. We'll have 8 times 4, that's 32. And then 8 times 1 is 8, and 3 is 11. 8 times 3 is 24, and 1 is 25. And then we'll finish this by adding, and we've got a 0. 7 and 2 is 9. 5 and 1 is 6. 1 and 5 is 6. 2. 26,690 is the end of our multiplication problem. Okay, great. Now let's go back and answer the question we were asked here. When multiplying 314 by 85, what numbers are multiplied to give the number 25120? When I look at the work I did here, I don't really see 25120, but we do ignore the ones column in that second number, and there's a reason for it. It's essentially, there's a 0 there. We just don't bother to write it. And so when we're asked about 25120, what we're being asked about is this number right here, and how did we get that? And that's what we got when we did this number multiplied by 314. And the key here is that it's not 8 times 314, it's 80 times 314, because that 8 is in the tens column. So 80 times 314 is what gave us this number. It's important to know that we bump over this place because we're multiplying by something that's already in the tens place. That's why we do that when we use the standard algorithm. Mental multiplication. What's the best way to write 5 times 44 so this can be done mentally? This could be a type it in question. It could be a multiple choice question, but what we're after when we're doing mental multiplication is we're looking for multiples of 10 or 100, things that are easy to multiply. So if I multiply that 5 times 2 and make it a 10, and divide this 44 by 2 to make it 22, I've got the same value down here. I doubled one, I halved another, so they're the same as each other. And when I multiply 10 times 22, well, I can do that in my head. It's just 220. And so that mental multiplication, a way to rewrite the problem, what we're looking for there is multiples of 10 or 100. And how do I get from what I've got to something that's a multiple of 10 or 100 that's an easy number to work with? Value of the quotient. This is one that is that went really well for you as a class. This is a problem that's sometimes hard for students, but this class did great with this one, so I'm really pleased with that. But if you divide a number that is larger than 75 by a positive number that is less than 3, what can you tell about the relative value of the quotient? And relative value of the quotient is relative to some number that's out there. What can we say for sure about the result of this division problem? The way that we attack these is, well, let's just say it's 75 divided by 3 to start with. That would be 25. So 25 is going to be our linchpin here. That's what we're going to build our answer around. And the problem told us we need something larger than 75, so bigger than 75, by a number that is less than 3. So what's going to happen here is our numerator is going to go up, our denominator is going to go down. What is that going to do to our answer? And it might just, you might be good right here with saying, well, then I know the answer has to be bigger than 25. But if you're not, that's okay. You try some numbers and say, all right, what if I make that one bigger? And if I make this one smaller, well, if I do that, I get 40. Okay, so that means if I make the top number bigger and the small number, or and the bottom number smaller, then my answer is going to increase. So that means that what I'm going to end up with here is an answer that is greater than 25. That one example lets me know, okay, this is what's going to happen. I'm not going to say anything about 40 because, yeah, 80 and 2 were really easy numbers to work with, but I just as easily could have done 76 and 2 and wound up with, what, 38? Or I could have done 75.000000001 and 2.999999999, and that's going to be really close to 25, but it'll be bigger than 25. And so the conclusion I can make is that the relative value of the quotient, it's going to be greater than 25. Limitation question. This is one we looked at sort of the end of last week when we were looking at how many bracelets could be made type of question. And that's what we're looking at here is Samantha's making necklaces. Each necklace uses 4 round beads and 7 cube beads. She has a package of 30 round beads and a package of 24 cube beads. How many necklaces can she make? And the key here is we have to identify what is going to be the limiting factor. What is it that's going to say, oh, that's where you have to stop making necklaces? And so we'll just look at each set of beads. We have 30 round beads, and I need 4 to make a necklace. So let's see, 30 divided by 4 is 7.5. I don't care about the 0.5. The round beads that I have would allow me to make 7 necklaces. And then I have to do the same thing with the cube beads. Let's see, I have 24 and I need 7 to make a necklace. That's going to be 3 point something. I don't care about the something. With the cube beads, I can make 3 necklaces. Well, it's whichever of these is less. Yeah, I could make 7 with my rounds, but I don't have enough cubes to do that. So the number of necklaces that she could make is 3 with the materials that she's got. Let me know if you have any questions on that one. All right, this has gone incredible. We're at the point where I'm going to go through this again with you. You'll see it. You saw it once before. You'll see it once again. When you go into an exam, I want you to be realistic and positive. Given your performance on the quiz scores over the last few weeks, I would expect you to go in this with a pretty positive attitude. I'm hoping it's going to go extremely well, but avoid perfectionism. There's an impossible amount of things to learn. No, we've just did a review over the main things I want you to know that in a relatively short amount of time. And also be realistic. You don't need to know every question to pass. It's certainly possible to miss several questions and pass. And you can miss a couple questions and get a really good grade. My knowledge of a certain topic is shaky. That could be, depending on when your appointment is. If you start studying to polish up those rough edges, you might have time to make sure you're comfortable with that. And you can ask questions of me when we get done here or by email right up to, well, when your exam happens. Don't be negative. I always do poorly on tests. Well, that's not true. I bet you did well on one of the quizzes we've had over the last few weeks because the scores on those have been really good. And always is a really big word. Probably that's just not true in general. And maybe you've got a better study plan for this one. You feel really confident with this material, so you're not going to be as nervous when you go into it as you might be sometimes. If I don't pass this test, I'm a failure. Absolutely not true. This is one test in one class in one semester of your academics. There's so much more to you than that this doesn't define you as a failure. I'm going to pass this test, but if I don't, I can bounce back. And that's true. Yes, it feels like, okay, Halloween's coming up. We're getting in there. We're in week 10 now. That is true. But we still have work to do in chapter 2, chapter 3, some chapter 4. We have another exam. So there's a lot of opportunities ahead to improve if this test doesn't go the way you want it to. Test is going to have a trick question. It won't on purpose. That last question we just worked on there. One of the answers is 7, one of the answers is 3. It's important for you to recognize which one of those is the correct answer for a question like that. But I don't think it's a trick, and it will never be my intention to throw something at you on an exam that you haven't been prepared for. And my favorite, this test is designed to let me show what I know, especially on this one. The quizzes have gone really well. I hope that's true for you. If you've done really well on the quizzes, this is one more just chance to really hit it out of the park. If the quizzes haven't gone as well for you as you hoped, this is a chance for you to say, you know what? I didn't get that the first time, but watching this review today, I feel much better about it. I hope that's where anybody who was struggling before, I hope that's where you've arrived at. So keep that in mind, that this is an opportunity to show what you know and earn some points in the process. But really, you're going to be asked a bunch of questions. Just answer them. Don't put more stress on it than that.